Okay, let's look at November 2004. That's for paper 1. Okay, so here in the diagram, ABC, yeah, we have ABC is an isosceles triangle. So we have our ABC here, A, B, and C. We're told that it's an isosceles triangle, so which means that this is equal to this. So we have 5 here. Then and BF is an altitude of the triangle. So BF is an altitude of the triangle. Then CFAE is a straight line. So we have CFA then E. We're given that it is a straight line, and also that AB is equals to BC, which is equals to 5. That AB is equals to BC, which is equals to 5. We've already done that. Then AE is equals to BF. So we have our AE equal to BF. Our AE be equal to BF. So this will be equal to 4. Then after that we also have our CD being equal to 12. Our CD is also equal to 12. So after having read the question, what we want to do is look at the first part. So apa pacheta separator triangles so that we can have more clear pictures. So the first one remains calculate the length of FC. So we're going to take triangle na FC. We have F, we have C, and then the triangle will be this one. So I will try to isolate that one. So this might be something like this, and then I have 4 here, then I have 5 here, then here I have FC. I have my FC. So if it is a triangle like this, it's a right angle triangle. So what's here is that this one that's opposite the 90 degree is our hypotenuse. Then this becomes an A, and this becomes a B. So we would make use of Pythagoras theorem so that we can find the value for FC. So now I'm saying my H squared is equals to A squared plus B squared. So my H being equal to 5, then squared is equals to my A is 4 squared, then plus my B is FC, and I say FC squared. Then here I take out my 4, you've entered the side na 5, so I innovate a 5 squared minus 4 squared is now equal to FC squared. In other words, we have my FC being equal to the square root of 5 squared minus 4 squared. Then to simplify for FC, 5 squared yangu is 25, then that will be 25 minus 4 squared yangu is 16. So here I have the square root of 25 minus 16, that's 9, being equal to FC. So 3 is equal to FC. So then after I get FC being equal to 3, I come to my diagram, then I replace with 3. So FC is equal to 3. So if this wasn't one, ABC was an isosceles triangle, it means that FC will be equal to FA. So this one will be equal to 3 again. Then I go to the next question. My next question says I should find the value of sine BCF. So for me to find the value of sine BCF, I go to my by my angle BCF. So it's BCF, so my angle is this one. So I just take the triangle again, something like this again. Then I have this angle as my reference point, so that would be what, BC, and then we have F. So I have this angle as my reference point, and then if it is my reference point, then this one becomes my opposite. So my opposite here is here, it's 4. Then the other part it's 3. So this one is the adjacent, it's equal to 3. I'm just taking from this one. Then this one, that's the hypotenuse, it's equal to 5. So I'm asked to find the value of sine of what, BCF. So that one will be equal to the opposite over hypotenuse. So if it is equal to opposite over hypotenuse, then this angle was my BCF. So my opposite will be equal to 4, and then my hypotenuse is equal to 5. So I find that for my sine BCF, it's equal to 4 over 5. Then I go to the next question. The next question asks me to find, that's number 3 here, cos ECD. So we go to ECD, we check here, we have let me have my X, we have E, C, and D. So if we get some working space here, so it's more like this. So we have E, then we have C, then we have D. So I'm asked to find the cos for this one. So here apparently I have two sides that are given. In other words, I'm given this side, which is from B to C. We have here from B to A, that's 4, plus A to F, 3, then plus F to C, that's 3. So that gives me 10. I have 10, and then here I have 12. That's C to D, that's 12. So if I have these ones, then I'm asked to find cos of this, and I don't have my angle, right? I can't necessarily find the value, but rather I would know that, check here, if I delete this, I want to see something. If you can see here, we have the obtuse angle. So this one is the acute of this obtuse. So these two angles relate, this one and this one. So however, I would have to firstly look at the relationship, and then we find our values. So Panapa, I would let me just put it to be clear here, and let me say F, and then B, and then here I have my C, and then my D. So we have here the acute, and we have the obtuse. So here would have cos, this will be cos BCF, and it's acute. So the arcuate of this cos will be negative, so it will be negative cos of what? BCF. So here we're asked, we had been given with our information, we've been given the values for this part, right? I'll put it again. So here, then we have this one, that's B, C, F right here. And then we were given 5, and we were given here that's 3, and we were also given here that's 4. So if this one is our reference point, then this one becomes our opposite, this one becomes our adjacent, and also this one becomes our hypotenuse. So for us to find the cos of this one, the cos of BCF would be equal to, for cos it's adjacent over hypotenuse. So if it is adjacent over hypotenuse, our adjacent is 3 over the hypotenuse here we have that's 5. So that would be 3 over 5. So for us it would be the relationship now between these two angles, this one and this one, is that this one is the negative of this one. So it means here we have, it will be minus of 3 over 5 if this one is equal to 3 over 5. So we now have that value. So the value for cos ECD, we have it, right? So our value for the cos of ECD, cos ECD, it is the same as this. Cos ECD is the same as negative of cos of BCF, which is equal to negative of 3 over 5. So this will be our value for cos ECD. So then if you didn't quite get this well, you check on my video for my obtuse angle rules, so that you can get the elementary things about it. Then we go to the next question. The next question states for us to find the area of the triangle ECD. So we go back here, the triangle, it's what? E, C, and then D. Then we're asked to find this. So by our our formula for the triangle, the area of a triangle says area is equals to half of AB sine theta. So here we have half of here would have our A and our B, then this will be the value for our theta. So here we have half of 10 by 12, then sine, then our sine, we have that sine of what? That sine of the angle ECD. Then also on this one we also have to look at finding ECD, sine ECD. So for us to find sine ECD, we come back here again where we have the relationship. So if we extend from F here, we go to E. So this one is still the same thing that we'll be using. Now you see that Kutipanapa, there is a relationship again between this part and also what? This part, but Panapa Kutaura in terms of sine. It's like Panapa, let me just rub a little bit. So the relationship iripo now is from an obtuse angle, and it is sine of what? sine of this one, that would be what? Of B C E, it will be the same as what? Sine for this one, that would be E C D, right? So sine BCE is the same as what? Sine ECD. So for this one here, this one on our side, it was sine ECD. So I'm now going to replace this sine ECD with the one that is known. So this one becomes half of then this one 10 by 12, that's 120. Then that would be sine of, then I go and take what? This one, which is sine BCE. Then this will be equal to, so this one will be 60. Then sine BCE, which is equal to, so that would be 60 multiplied by, then I have to find my sine BCE. So for my sine BCE, the options are this part to get it. So my BCE, I'll just take it up to here F. Instead of having to E, I'll take it to F so that I can make use of this one here, that is right here. So I'll just wait a bit. So now apa zvakuitika ndezvekuti ndakuda sine what? BCE. So if I want my sine BC to E, I'll just replace here with F, right? If I want that now, this one is my opposite, so my adjacent is this one, my hypotenuse. So sine that sine will be equal to what? There's a BCE, or BCF will be equal to opposite over hypotenuse. So if it is opposite over hypotenuse, my opposite here is 4 and my hypotenuse is 5. So I have 4 over 5. So this 4 over 5 is the one that I'm now going to take and now going to replace for sine BCE, which is 4 over 5. So I would say 60 by 4 over 5. So 60 multiplied by 4 over 5, and that will give me 48. So my value there is 48. So the units were in centimeters, so it becomes centimeter square centimeters. Then I go to my last question, in which I'm asked to find the value of ED squared. So for me to find ED squared, I go back, then I extract the triangle with ED. So you find here we have E, then D. So the triangle with that one is this one, which is what? E, C, and D. So I extract my triangle. So here, then we have E, then we have D, we have C, then we have 10, and then we have 12. And here we have ECD as my angle, and then here we have ED as the side, right? So if it is like this, we have two sides and we have a known angle. This angle is known, right? Because we once showed you that it is known, right? Because it's 2900. So this one becomes our X, this one becomes our A, this one becomes our B. Now then apa patinenge takushandisa cosine rule, takuti manje x squared is equals to a squared plus b squared minus 2 that's minus 2 AC cos, that's AB, sorry, AB cos theta. Here then I have ED, so I say ED squared, then my A is what, 10 squared, plus B, my B is 12 squared, then minus, that's 2 by 10 by 12, then cos of ECD. Then here, that's ED squared. My ED squared will be equal now to yeah, that would be 10 squared plus 12 squared, that gives me 244, minus then 10 by 12, that's 120, by 2, that's 1, that's 240, then cos of ECD, which is equal to 244, subtract 240, and now we want to replace the cos ECD. So remember, cos ECD, we once had cos ECD, which was here, and the value for cos ECD is minus 3 over 5, and we place minus 3 over 5. So for this, we now say this is our ED squared, ED squared. So this one will be 244, then minus 3 over 5 by 240, it will give me minus 3 over 5 by minus 240, it will give me plus 144. Then at the end of the day, we have 388 being equal to ED squared. So this would be in centimeters, right?